Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, I'll be tackling the 7th question from the preliminary exam which was written in the year of 2023 at the Torah Academy. Please do expect a total number of 12 videos since the question paper had 12 questions in total, and that simply means each and every question will have its own video. And please, guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and, most importantly, your final examination. So please, guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay, we are told that in the diagram below, the graphs of f of x and g of x are shown. The graph of f cuts the x-axis at C and D, the y-axis at B, and has a turning point at A, and the line x is equal to 1 is the axis of symmetry. Okay, so the line of x is equal to 1 is the axis of symmetry of our quadratic function. Are together? So I now know that the x value at my turning point is just equal to a positive 1. Then we will find the corresponding y value as well. No? Okay, and then the line of the statement continues, right? The line of y is equal to negative x minus 3 is an axis of symmetry of the graph of g of x, and this line passes through point A and B. It passes through point A and B. Remember that, guys, A is the local minimum of our quadratic function, and B is the y-intercept of our quadratic function. Are you together, guys? So I can conclude that the y value there at B is just negative 3. So I now know the coordinates of B. X is 0 because B is on the y-axis, and the corresponding y value will be negative 3. Okay, and then the graph of G passes through the point 3 and negative 2. Okay, the first thing they want us to do, guys, is to show that the coordinates of A are 1 and negative 4. Remember that, guys, A also lie on the line which is equal to negative x minus 3, right? So we want to find y if x is equal to 1. I know the x value at A is equal to 1, so I want to find the corresponding y value. Therefore, y is just equal to negative 4. That's why when x is 1, y is just equal to a negative 4. Are you together? And then now we must determine the coordinates of B. B is the y-intercept of both the quadratic function as well as the axis of symmetry. So this is the y-intercept over there. So the coordinates of my y-intercept, I know on the y-axis, x is always 0, and the corresponding y value will just be equal to a negative 3. And then I'm supposed to determine the equation of f of x. I'm supposed to determine the equation of f of x, right? F of x is our parabola. Okay, what do we know about our graph? I know that f of x equal to x minus 1 squared plus q rather, ne? But now I do know, guys, the value of q, right? Because q is just the y-intercept at the turning point, and we did find the y value there to be equal to negative 4, right? So I'll simply write f of x is just equal to a into x minus 1 squared minus 4. Are you together? The only thing I need to find, guys, is the value of a. How can I find a? By just substituting an extra point that we have. Ne? We know the coordinates of b. B lies on the graph of f of x, and b is our y-intercept, where x is 0 and y is negative 3. Y is negative 3 whenever x is equal to 0. If I take this guy to the other side, I'll have negative 3 plus 4. This will just give me 1, and then I'll have a on the other side. So therefore a is just equal to 1, and hence f of x will be equal to x minus 1 squared minus 4. I don't need to write 1 there. I know that a is equal to 1. You can leave your graph like this, guys, or you can simply expand it. Ne? They didn't tell us to leave our graph in inward form, so we can leave it like this. You'll still get your full marks, or you can further simplify it by just removing the brackets. Ne? So this will further be equal to x squared minus 2x plus 1, that's minus 4, and hence there's x squared minus 2x minus 3. So you can leave your graph like this or like this. It's still the same thing, guys. Ne? Okay, and then now they want us to find the equation of g. Where is g? G is our hyperbolic function, right? And I know that g of x will be equal to a over x minus p plus q. Okay, I have x minus, we do know, guys, the equation of the axis of symmetry. Ne? At point A gives us the equations of our asymptotes. At point A, x is just equal to 1 and y is just equal to negative 4. So if that's the case, that means I'll have negative 1 over there and negative 4 as well over there. Are you together? The only thing I need to find is the value of a. And since my graph is on the first and the third quadrant of my asymptote, I'm expecting to find a positive value of a. Are you together? I'm expecting to find a positive value of a. How can I do so? By just substituting an extra point on the graph. So I know that y is just equal to negative 2 if x will be equal to 3. Are you together? And then I'll take this to the other side. I'll have negative 2 plus 4. This will give me a positive 2 is equal to a all over 2. And therefore a is just equal to 4. Hence, g of x will just be equal to 4 over x minus 1 minus 4. So this is the equation of g of x. Ne? G of x is just equal to 4 over x minus 1 minus 4. Then now we are told that h of x, we will be able to find h of x if ever we reflect the graph of f of x on the x-axis, number 1, and then translate it 2 units up. Okay, they want us to determine the maximum value of f of x. Since you know, guys, the minimum value of x, the minimum value of f of x, guys, was at was point A, right? Point A was just 1 and negative 4. Okay. The first thing that they did, guys, was to reflect the graph of f of x on the x-axis. If you reflect the graph on the x-axis, you are also reflecting all the coordinates on the x-axis, right? So by reflecting the graph on the x-axis, that means we must also reflect this point on the x-axis as well, né? And whenever you reflect on the x-axis, only the sign of y changes. So the new point will simply be 1 and positive 4. Are you together? That's the first transformation. Then the second transformation, guys, was to translate the graph 2 units up. By translating the graph 2 units up, we are also translating all the points of the graph 2 units up. So I will further transform this by translating it 2 units up. Ne? So a double prime will simply be 1 plus, if I'm translating this point 2 units up, I'm just supposed to add on the y value. So it will be 4 plus 2 units, that will be just 6. So the maximum at point A, rather the new maximum of h of x will just be 1 and positive 6. Okay, and then now I'm supposed to determine graphically the values of x, whereby the derivative of f and g of x, the product of the derivative of x and g of x are less than 0. Let's check this over here. Né? Let's erase this. Let's erase this so that you can be able to scan our graph properly. Okay, you must just find the values of x, guys, whereby the derivative of f of x times the product of g of x will just give us a negative number. Né? Okay. If, guys, you get a negative number, that simply means you're multiplying two things that are not of the same sign. One of them has to be positive, while the other has to be negative. Are you together? So over here, guys, if I check here, over here, since they're dealing about the derivative, né? That means it's the values of x whereby the graph of f of x is increasing or decreasing. Are you together? Just focus on f of x alone. Are you together, guys? If your graph is decreasing, just assign a negative, and if your graph is increasing, just assign a positive. Né? Scanning your graph, moving from left to right. Is your graph going up or down? Our graph is going down, so that means the y value is decreasing. So it will be negative, 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 because the graph is decreasing. At the turning point, the graph is stationary, and then it will start increasing, and then we'll have positives over there. Positives, 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 positive. And then we are focusing on g of x, right? For g of x, guys, we are just going to focus on the function value. I know that my graph will be positive if and only if it's below the x-axis, and it will be negative if it's above the x-axis, right? So my graph is just negative over there because it's below the x-axis. It is also negative as well over here, and then now it will start being positive. Are you together? I'm looking for a region whereby my two graphs will have different signs. Right? Over here, guys, over here, if we can check properly, né? From the right hand side of the x-intercept of our hyperbola, we have two opposite signs. Are you together? The other graph is continuously negative, whereby the graph of f of x is continuously increasing. Are you together? G of x has a positive sign, a negative sign rather, whereas f of x has a positive sign. If I multiply these two things, I'll forever get a negative value. Okay, so the only thing that, guys, we're supposed to do right now is to find the x-intercept over there, because let's say if the x value is a, that means this statement is true whenever x is greater than a. Are you together? So now, guys, let's go and find our x-intercept. Let's go and find our x-intercept. Remember that, guys, g of x has an x-intercept over there, né? And g of x is just equal to 4 all over x minus 1 minus 4, right? For the x-intercept, guys, y is always 0. Y is always 0, and then I'll simply have 4 all over x minus 1. This is just equal to 4, right? Okay, if I take the negative 4 to the other side, it will be positive. Right, together, so I'll have positive 4 is equal to 4 over x minus 1, and then I can cross multiply. I'll end up having 4 times x minus 1 is equal to 4. If I divide both sides by 4, I'll end up having x minus 1 is equal to 1, and hence x is just equal to 2. So the x-intercept over there, the x-intercept is just equal to 2. Are you together? The x-intercept, x is just equal to 2, right? So from the right hand side of 2, I can see that my graph will continuously be below the x-axis, and the parabola will continuously increase. So if I multiply any of the two x values from in any of the two x values from the two graphs whereby x is greater than 2, I will simply find a negative answer. So the answer over here, guys, just say x is greater than 2. This is the only answer. I believe it was 4 marks because we were supposed to find the x-intercept first. Né? You can write your answer like this or write it in interval notation. X is an element of 2 and infinity. Like that. Are you together? So x is greater than 2 or x is an element of 2 and infinity. Okay, and then now we are told that if h prime, or rather if f of x represents h prime of x, okay, the graph of the derivative function of h for which the values of x for which values of x will h have a minimum turning point. Okay, we are told that, guys, h prime of x is equal to f of x, right? Okay, h prime of x is just equal to f of x. So they are asking us for which values of x will h have a minimum value. Let's erase these things over here so that you can write properly. Okay. For minimum values, guys, please remember that for minimum values, let's say a is an x value at turning point, or rather a is an x value at minimum. Are you together? This simply means that your graph, or your graph should be decreasing whenever it's approaching a. Are you together? So graph should be less than 0 when x is also less than a, and then the graph should be increasing whenever x is greater than a. Are you together? So that means your graph will be like this. Your graph, before it gets to a, it will be decreasing, it will be moving downwards, and then reaches a, whereby it's stationary momentarily, and then it will start increasing like this. So this is your local minimum. Are you together? So in this case, guys, my graph is decreasing wherever y is negative. Why am I saying that? Because h prime of x is equal to f of x, right? Over here, guys, whenever the graph is decreasing, that simply means your graph is negative, or rather it's moving in a negative direction. Are you together? So the only way whereby f of x is negative, that's when f of x is below the x-axis, guys. Are you together? Remember that the x values over here will represent my turning points, my stationary points. Are you together? One of them will be a maximum and the other will be a minimum. Are you together? So above the x-axis, I will have positives over there. Positive, 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 positive. Then you should ask yourself, for you to find a local minimum, there's x which is equal to d, another x is equal to c, right? When x is equal to d, I can see that my graph is below the x-axis. That means the original graph was decreasing. When x is less than d, the graph is decreasing. And then when x is above d, when x is greater than d, the graph is increasing. So this x value there at d is the local minimum, and hence the x value at a is my local maximum. Are you together? So did they want us to find the numerical value? Let me check how many marks was this. If f of x represents h, the graph of the derivative function of h, for which values of x will h have a minimum? For which values of x will h have a minimum turning point? Ah, man. Did we find these coordinates of D? We didn't. Okay, it's cool, guys. Whatever coordinates of D there, let's just find it. Remember that f of x initially is just equal to x minus 1 squared minus 4 together, and D is just on the x-intercept of f of x. So I'll simply have 0 is just equal to x minus 1 squared is minus 4, and then positive 4 is just equal to x minus 1 squared. And then if I take square roots on both sides, I'll end up having x minus 1 is equal to positive 2, or x minus 1 is equal to negative 2, and hence x is equal to 3, or x is just equal to negative 1. So the x value at D is equal to 3, the x value at C is equal to negative 1. So we will have our local minimum whereby x is equal to 3. We'll find our local minimum for h of x when x is equal to 3. Okay, find the equation of h of x in that form. Remember that, guys, h of x is the derivative of h of x is basically equal to f of x, right? So f of x, we found f of x to be equal to x minus 1 all squared minus 4, and then that will give us x squared minus 2x minus 3. If ever we remove the brackets, right? Okay, we do have our h of x, which is just equal to ax cubed plus bx squared plus cx, right? That means h prime of x will be equal to 3a, and then 2bx plus c. The derivative of h of x will be equal to that, né? So since these two things, guys, are equal, we can therefore conclude that 3a, I forgot to write over there, it's 3ax squared, right? Whenever I find my derivative. So this simply means that 3a will be equal to 1, 2b will be equal to negative 2, and then c is just equal to negative 3. So 3a is just equal to 1, that means a is just 1 over 3, and then b is just negative 1, c is just equal to negative 3. I can therefore go and substitute. H of x will simply be equal to 1 over 3 multiplied by x cubed minus x squared minus 3x. So this will be the graph of h of x, guys, né? And then the last question, we are being asked that how can the domain of f of x be restricted in order to make the inverse a function? How can the domain be restricted? Okay, you can simply restrict your domain like this, guys, né? You can simply restrict your domain like this. Your domain can be restricted like this only if x is greater or equal to 1, so this will be only a function together, and hence the thingy, excuse me, and hence the inverse function will only be like this together. Or you can say x is less or equal to 1, and then your inverse function will just be like that together. So you can restrict your domain by just doing that, né? X is greater or equal to 1, or x is less or equal to 1. That's how you're supposed to restrict your domain. And that's how, guys, we're just supposed to tackle that long question over there. So please, guys, do stay tuned and wait for more videos. Thank you for your time.